Greetings, this is Chemistry with Nav. In this video we're going to take a look at buffer solutions, and hopefully you know that a buffer solution is a solution that resists changes to its pH on addition of small amounts of either acid or alkali. And an acidic buffer is usually what's asked for, unless of course you're doing the IB, in which case you do need to know about basic buffers as well. But an acidic buffer is made by putting a weak acid in the presence of its salt or its conjugate base, which is the same thing. And there are two main ways of making acidic buffers. You can literally add the solution of weak acid and the weak acid salt. So that's the very direct method. The example of that, the most common, would be putting ethanoic acid in with something like sodium ethanoate, where the ethanoic acid is CH3COOH and the sodium ethanoate is CH3COO minus Na plus. So there's the conjugate base, the CH3COO minus. The second method, which is slightly more roundabout, is by putting a strong base with an excess of weak acid. So we might choose sodium hydroxide, and let's use ethanoic acid again. So what happens is that your sodium hydroxide, your NaOH, reacts with the ethanoic acid, and that ends up forming your CH3COO minus Na plus. So we've made the sodium ethanoate, the salt, in situ. We've also created some water from the neutralization of the acid and the base, but because there is an excess of the weak acid, we still have some weak acid left over, so now we have the weak acid in the presence of its base, of its conjugate base. Okay, now let's move on to the calculations of these things. So we know that for a weak acid HA, you can write a Ka expression, which is that Ka is equal to the concentration of H plus times the concentration of HA minus over the concentration of HA. But we're slightly changing this. This now actually is coming from the salt, because we have artificially increased the A minus concentration by adding a salt solution. We also know that the HA is literally just from the weak acid, and because we assume the weak acid to dissociate to such a tiny extent that the concentration of HA is considered to be the same as it was at the start. So what we can do is we can just slightly rewrite this, that Ka is equal to H plus concentration of salt over the concentration of acid. Now that may not seem like a very big change, but if you are trying to find the pH of a buffer solution, as so many questions ask you, then you can rearrange that for H plus, and H plus is simply equal to Ka concentration of acid over the concentration of salt. And it's useful to think of the acid to salt term as a ratio. That is your acid to salt ratio, as quite a lot of exam questions now are asking for you to find that ratio, or giving you that ratio as part of the question. But we can just do one more tiny development of that even, which is that H plus is equal to Ka, the moles of acid over the volume, all over the moles of salt over the volume. But because a buffer solution has to be created in just one container, those volumes will cancel and leave you quite simply with Ka N acid over N salt, where N is the number of moles. So in fact, that can be your simplest expression for calculating H plus for a buffer solution.